All right, let's jump right in. I want you to think about something for a second. What if we could fundamentally change how we make almost everything, from the food on our plates to the medicines we rely on? Well, there's a technology doing just that. It's called precision fermentation, and it all starts with one simple, mind-bending question.
It sounds like something straight out of a sci-fi movie, right? But here's the thing. This is not a hypothetical. This one question is at the very heart of a technology that is completely rewriting the rules of manufacturing as we know it. I mean, the promise here is nothing short of revolutionary. We're talking about breaking a chain that has tied us to traditional agriculture for millennia. We're talking about decoupling the production of some of our most basic ingredients from land, from livestock, from all of it.
And let's be super clear about this. This is not another milk alternative like oat or almond milk. We're talking about real dairy protein, molecularly identical to the original. The only difference is the factory it comes from.
So how on earth is this even possible? The answer lies in this really powerful process called precision fermentation.
Now, the name might sound a little technical, but the core idea has been a quiet workhorse in science for decades. We've been using this to make things like insulin for diabetes and rennet for cheesemaking since the 1980s. So the key takeaway here is this. It is a proven, reliable technology that is now being unleashed in some truly incredible new ways. So how does the magic happen? Well, it all starts with what's called strain engineering. Basically, scientists give a microbe, like yeast, the precise DNA recipe for a milk protein. Then it's time for fermentation. The microbes are put into these huge tanks. They honestly look a lot like what you'd see in a brewery, and they're fed simple sugars. As they feast, they become tiny factories, cranking out the exact protein we want. After that, it's all about purification, to filter the protein out, drying it into a useful powder, and finally functionalization, where it's fine-tuned to do a specific job, like creating that perfect, gooey cheese pull. Now, the process seems pretty straightforward, but there has been this massive hurdle, a huge roadblock that's kept this technology from completely taking over. And it's the challenge of going from a tiny lab to a massive factory. And this is the absolute core of the issue. Scientists have a name for it, the lab-to-factory gap. You see, a strain of yeast that works perfectly in a 1-liter flask in a lab can completely, utterly fail when you try to put it into a 10,000-liter industrial fermenter. This quote from a research paper just nails the problem. For the longest time, the whole process was sequential. First, scientists would perfect the microbe in the lab, and only then would they try to design a factory process to fit it. Think about that. It's like designing a Formula One engine and then trying to build a car around it. It's just backward and incredibly inefficient. So, to bridge this lab-to-factory gap, innovators had to basically throw out the old playbook. A completely new way of thinking was needed. And the big breakthrough was to stop thinking in sequence. Instead of designing the microbe and then the factory, the new approach is to design both of them at the exact same time. This lays out the difference perfectly. On one side, you've got the old way, a process pretty much based on hope. You design it, build it, and cross your fingers. But on the other side is the new way. Using these super powerful computational models, like one called Simulnock, engineers can design the microbe and the process simultaneously. It's like designing the race car for a specific racetrack, ensuring a perfect match right from the start that just maximizes performance and finally solves that scale-up problem. And with that massive problem on its way to being solved, the floodgates have just burst open. Precision fermentation is now set to completely transform global industries, and you can bet investors have noticed. We are talking about more than $4.8 billion in all-time investment. That is a massive signal of confidence in where this whole field is going. And just look at these growth projections. They are absolutely staggering. The market is expected to jump from around $5 billion next year to over $34 billion by 2032. That's not just growth, that's explosive. So what can this technology actually make? It goes so far beyond just dairy. In food, we're talking animal-free egg proteins, fats, even the heme that makes plant-based burgers bleed. In medicine, it's producing insulin and vaccines, and in material science, it's creating everything from animal-free collagen to spider silk proteins. The applications are truly endless. So where does this all leave us? The promise is obviously immense, but the road ahead still has some significant challenges we have to overcome. You know, the path forward is really a balancing act. On one side, you have these powerful drivers like consumer demand for sustainable products and huge advances in AI. But on the other, the industry is grappling with high costs, complex regulations, and the enormous challenge of actually building out the infrastructure we're going to need.
And this brings us to the final, crucial question. The potential for this technology to build a more sustainable and efficient world is undeniable, but navigating the economic and regulatory landscape is what's going to determine the speed of this revolution. The technology is here, so the real question is, how quickly can we scale the future?